Hey everyone, and welcome to DevOps Corner. If you've ever worked on a Kubernetes cluster that's starting to grow, you know that feeling. Things get a little chaotic. Who has access to what? Is production really safe? Well, today we are going to demystify the one tool that brings order to that chaos, Role-Based Access Control, or RBAC. If you want more deep dives like this, do me a favor and hit that subscribe button and like this video. It really helps us out. All right, so here's our game plan. We're going to cover everything you need to get started. We'll kick things off with why this is so incredibly important. Then we'll break down the core building blocks of RBAC. After that, we'll get into the weeds on namespace versus cluster-wide permissions, see it all in action with some real-world code, and then we'll wrap up with how you can take your very first step to securing your own cluster. So let's start at the very beginning with a pretty fundamental question. Look, when you're the only person touching a cluster, life is pretty simple, right? You're the admin. But the second your team starts to grow, giving everyone the master key is, well, it's just a recipe for disaster. You absolutely need a way to answer that crucial question: who gets to do what? Because without proper controls, you're just inviting chaos. I mean, think about it. A developer accidentally deletes another team's entire deployment. Or maybe someone stumbles upon sensitive production secrets they should never see. But it's not just about preventing disaster. It's also about enabling your team. You don't want good developers stuck waiting for the one and only cluster admin just to make a simple change. And that brings us to the solution, Role-Based Access Control, or RBAC. This is the native, built-in Kubernetes way to handle all of this. And the core idea of RBAC is honestly brilliantly simple. It splits the whole problem into two basic questions. First, what actions are even allowed? And second, who is allowed to perform those actions? That separation right there, that's the key to understanding everything else. So let's talk about the what. That's a role. A role is a Kubernetes resource that's literally just a set of permissions. It's got rules that pair up verbs, things like get, list, or delete, with nouns, which are just the resources themselves, like pods or deployments. Now, a role by itself doesn't actually do anything. It's just a blueprint of permissions. To actually give those permissions to someone, you need a role binding. The role binding is what answers the who question. It takes a subject, that could be a person, a whole group of people, or even an automated process called a service account, and it connects them to a role. That's what brings the permissions to life. Okay, now here's where it gets really interesting. It's all about how Kubernetes handles the scope of these permissions, because not all permissions are created equal, and where you grant them, well, that matters a lot. Kubernetes gives you two levels of control here. You've got a regular role, which is tied to a specific namespace. It only grants permissions inside that one little box. But then you have a cluster role, and just like the name says, it's cluster-wide. It can grant permissions to resources in every single namespace, and even to things that don't live in a namespace, like nodes. And this is the perfect way to think about it. A role and its role binding are like a key to a single room in a huge building. A cluster role and its cluster role binding, though, that's the master key. It's incredibly powerful, and you have to be really careful with it, because it applies everywhere, including to any new namespaces you create down the road. All right, theory is great, but let's get our hands dirty and look at some practical examples. Seeing the actual YAML really makes this stuff click. So here's a super common scenario. Meet Alice. She's a developer. We want her to be able to see the pods for her project, which lives in the application namespace. But, and this is a big but, she shouldn't be able to see or change anything else. This is the perfect use case for a simple namespace-scoped role. So first, we create the what. This is our role resource. You can see we give it a name, pod reader, and this is the critical part, we specify namespace application. Under rules, the verbs are all read-only actions: get, watch, and list. And the only resources she can touch? Just pods. Next up, we create the who. This is our role binding. Under subjects, we specify the user, Alice. And then the role ref points directly back to that pod reader role we just made. As soon as we apply this YAML, boom, Alice can now view pods, but only in that one single namespace. Okay, now for a more powerful user. Let's meet Bob. Bob's an operator. He needs to manage deployments across the entire cluster. But to prevent any, oops moments, we want to make absolutely sure he cannot delete anything. This is a job for a cluster role.
So here we define a cluster role called deployment modifier. And notice right away, there's no namespace field. That's because this thing is cluster-wide. In the verbs, we've given him create and update, but we've very deliberately left out delete. He can manage deployments and pods anywhere, but he just can't remove them.
And to finish the job, we create a ClusterRoleBinding. This is what connects Bob's service account to that powerful deployment modifier role. This binding grants him those permissions across every single namespace in the cluster. So now he has all the access he needs, but without the power to cause a major accident.
So you're probably thinking, okay, this is great, but how do I actually start implementing this in my own cluster? It might seem a little complex, but you can approach it in a really systematic way.
Really, it's just a simple 3-step process. First, just figure out what different people or apps on your team actually need to do. Just map it out. Second, define your roles and cluster roles based on the principle of least privilege. That means you start with the absolute bare minimum permissions they need to do their job and nothing more. And finally, you create the bindings to hook it all together. And at the end of the day, RBAC isn't just a security tool for locking things down. When you do it right, yeah, it makes your cluster way more secure, but it also empowers your whole team. It lets developers work on their piece of the puzzle independently, safely, and without stepping on anyone else's toes. And that really is the key takeaway here. RBAC isn't a set it and forget it kind of thing. It's a living, breathing part of your cluster's configuration. It has to adapt as your teams and your applications evolve. It's the essential tool for managing your cluster's security and its sanity over the long haul. I really hope this explainer helps you build a more secure and a more organized Kubernetes cluster. If you found it useful, please go ahead and smash that like button and share it with your team. Thanks for watching, and we'll see you in the next one.